Hi, I'm Edgar, and I'm a software engineer at Google.
Hi, I'm Becky, and I'm a software engineer at Google. So Edgar, the question I'm going to give you today is, I'm going to give you a collection of numbers. And I need you to take this collection of numbers and find a matching pair that is equal to a sum that I give you as well.
Okay.
So for example, the collection of numbers could be 1, 2, 3, and 9. And the sum that I'm looking for is 8.
Okay.
And then another example, just for another set of numbers, could be a 1, a 2, a 4, and a 4. And then again, the sum that I'm looking for is 8.
So in this case, I guess what I'm trying to figure out is you're looking for a pair of numbers that add up to 8.
Yes.
Right. So in this case, there isn't a pair of numbers that add up to 8.
That is true in this example.
And in this case, it is because the 4 and 4 add up to 8.
Correct.
Okay.
Yes.
So this would be like no, and this is yes. Okay.
Yes, you ultimately have to tell me if the pair exists.
Okay. So how are these numbers given? Can I assume that they're kind of like in memory, an array or something?
Yeah, they're in memory. You can go with an array. You can also assume that they're ordered in descending order.
Okay. Oh, interesting. Okay. So how about repeating elements? Can I assume that there will be, like for instance here, what if I didn't have that 4? Could I use like the 4 and the 4 to get that 8?
You can't repeat the same element at the same index twice, but certainly the same number may appear twice. Like
Okay, so like that would be a yes. How about these numbers? Are they integers or are they floating point or?
You can assume they'll always be integers.
Okay, negatives, positives?
Negatives could happen.
Okay, cool. So, well, the simplest solution, of course, is just comparing every single possible pair. So I could just have 2 for loops, one scanning the whole thing, and then the second one starting from, let's say you have the I loop and then the J loop starting from I plus 1 so that I don't repeat the same value, and just testing all of them if the sum is equal to the target sum. I mean, that's obviously not very efficient, but that would be like a way to solve it.
That would work. It certainly would be time consuming, I think, as far as clock cycles is concerned. So is there any kind of example that could be a little bit faster?
Yeah, I think that would be quadratic. So better than quadratic. Well, since it's sorted, so okay, I guess I need to figure out when I have a number, what I'm looking for is if there's another number that sums to 8. So if I have a 1, what I need to figure out is if there's a 7 somewhere in the array. And if that's the case, if it's sorted, then I can just do binary search. I guess if I go here and I binary search for a 7, then I go here and I binary search for a 6, which is the complement of that. And when I go here, I binary search for a 5, and in the end, I just don't do anything. And so in this case, I would solve it like that. So that's a bit better than quadratic. I guess binary search is a log algorithm in a sorted list.
Also a good answer.
Okay.
But still kind of slow.
Okay.
So what if you took a look at, instead of going a binary search, which is unidirectional, what if you started with a pair of numbers to begin with?
Okay.
And then worked your way sort of inward from there.
Let's see. So if okay, let me try to bound this thing. So the largest possible sum, I guess, would be the last 2 values.
That would be the largest possible sum,
and
yes.
The smallest possible sum would be the 2 smallest, right? So anything in between. Okay. So the range of the possible values is that, right? So there's nothing that is probably small. There's nothing that can be smaller than this value.
Right.
There's nothing that can be larger than that value.
And you have somewhere to move from.
That's Okay, so if this sum is 10 in this case, it's too large.
Mm-hmm.
So I need to find a smaller sum. So I could just sort of move this one over here. And if that is too small now, then I need to move that one over there. Okay, so I think I can just do it with that in a linear solution. Just moving at each iteration, I either move the high one lower if my pair is too large, and I move my lower higher if my pair is too small. And I end whenever I either find two, like in this case, I either find a pair that adds up to 8, or whenever they cross. So at every point I'm moving one of them, so they would have to at least cross. And I move exactly one, so that means that it's linear. Yeah, so that would be a way of solving that problem.
And how does it make that faster than a binary search?
Okay, so in the binary search case, I was doing log for finding, but I had to repeat that for every element. So that was an n log n solution. In this case, I just need to do that scanning the one time. So it's a linear solution. So that's faster.
Right. Okay. So before, maybe we could get to coding it, but before we do that, maybe you could explain. So you explained it in a non-working example. Maybe you could follow through that same process in a working.
Okay, yeah, so here I would start with this and that, right? So it's 5, it's smaller than 8, so I move this one here. So that's 6, that's smaller than 8, so I go here, and then that's 8, so that's true, and I return.
Excellent.
Yeah, I think that would work.
Okay, so what coding language would you prefer to do this in?
I prefer C++, if that's okay.
C++ works.
Okay.
All right, go for it.
Perfect, let's see. So, okay. Now I realize that I haven't figured out what I need to return. So do I want the pair, the indices of the pair, or whether I just found it or not?
So for the purposes of the example, we'll go with whether you found it or not. But let's say you were going to return the pair. How could that become a problem if there was no pair?
So, I mean, building the pair would be easy, right? So I would just return the pair. If I didn't find it, then I would need to return some sort of like Boolean. So I guess I could make a data structure that has a Boolean that denotes whether the pair is valid or not. Like has it been found? So like a bool found, and then a pair values or something like that.
Combine those together.
Wrapped.
Yeah.
And then this is the thing that you return. I mean, it's not very elegant, but it's workable.
Rather than going with a custom object, maybe we'll just return a Boolean then.
Okay, that makes it a lot easier, yes.
But it's good to know that you thought about what you might have to do if there is no viable result.
Okay, so let's just call it pass pair with sum, I guess.
Sure.
And so I'm okay just receiving whatever. I would like to receive it as a vector, say.
Vector's fine, yeah, sure.
And we said ints are fine.
Ints are fine.
This is my data. And then I have an int, which is my sum. Okay, so like I said, I want sort of an int, my low, which is 0. Then my high, which is the data size -1. And then what I'm going to do is while these are, while my low is strictly lower than my high, okay, as soon as they are touching, then I know that I can't guarantee that they're different, so that's where I should stop. Okay, while my low is less than my high. And this also solves the problem of what happens if this is empty. Because then if this is empty, this would be a -1, and then that would be violated, so I would never enter and access any of the values. So that's fine. So while low is less than high, I guess if my data at low plus my data at high is the same as my target which is called sum, then I have found it. That's it. That's my pair. And here's where I would construct that pair if I needed to return it. But like you say, for now, I can just return true. Now, if this is larger than sum and this is lower than sum, so I think I'm better than just doing it 3 times. I'm just going to store it in a variable, which is my s. Is that, and then say if s is my sum, then return true.
Okay, I'm going to stop you right there.
Okay.
Excellent solution. I see what you're getting at here, but now I'm going to throw a little wrench into the mix for you.